Hello students, myself Dr. Mrs. Mugdha Kango from Department of Electronics and Telecommunication Engineering, Modern College of Engineering, Pune, would like to talk on electromagnetic interference and compatibility. Contents to be covered: Introduction to electromagnetic interference, types of EMI, radiated and conducted EMI, difference between EMI and EMC, EMI sources and EMI minimizing or shading techniques for EMI, various EMI and EMC standards. Introduction to electromagnetic interference. EMI or EMC is the acronym for electromagnetic interference and compatibility. Electromagnetic interference (EMI) is unwanted noise or interference in an electrical path or circuit caused by an outside source. It is also known as radio frequency interference. It can cause electronics to operate poorly, malfunction, or stop working completely. Electromagnetic compatibility is the ability of electronic or electrical equipment and systems to function acceptably in their electromagnetic environment. The goal of EMC is to correct operation of different equipments in a common electromagnetic environment. There are various sources of EMI. EMI can be caused by natural or human-made sources. Natural sources. There are some sources in the natural world that can produce powerful enough electrical field to affect electronic devices. For example, lightning can produce strong electrostatic discharges and magnetic pulses. Solar storms and solar flares emit highly charged particles that can cause problems with satellite and terrestrial communications. Cosmic radiation has been known to cause bit flips in electronics. These all are the natural sources of the electromagnetic interference. Then we have the human or man-made sources. Human-made EMI can come from many places. High-power radio and electrical sources can cause unwanted EMI. Malfunctioning or improperly designed consumer devices can cause EMI in other devices. For example, washing machines, mixers, grinders, electrical motors and generators, aircraft navigation, military equipments, computers, UPS, fast switching electrical devices, cell phones, microwaves, AM and FM radios, baby monitors, X-ray and MRI machines. These all are the devices which generate the man-made EMIs. Using high quality electronics, electrical shading and modern error correction methods, we can reduce impact of EMI. Take a break or pause as a reflection spot and think on the one of the question: which are the sources of EMI? Dear students, you have to elaborate all the sources in detail. Okay. Then types of electromagnetic interference. In EMI, there is a source, a path and a receptor or victim. There are several types of paths or methods of transmission of EMI from the source to receptor. So this is source, this is path and receptor or victim. There are two types of EMIs. One is radiated EMI, second one is a conducted EMI. Radiated EMI happens when a high power transmitter or electrical device produces a radio frequency that is picked up and causes unwanted effects in another device. If there is an EMI and the source and the receptor are far apart from each other, then it is likely a radiated EMI. Some examples of this would be a broken kitchen microwave, causing a computer to reboot, or old wireless telephones causing Wi-Fi to drop. Such type of examples we can realize in daily life. Then next one is the radiated EMI can be subdivided into two parts. One is a narrowband and broadband interference. Narrowband EMI only affects a specific radio frequency and is commonly from a radio transmitter. Broadband, broadband EMI affects a large portion of the radio spectrum at many frequencies and is commonly caused by malfunctioning of the equipment. Conducted EMI happens when there is a physical electrical path from the source to the receptor. This is often along power transmission lines. Some sources may be a large motor or power supply. An example of conducted EMI is turning on of a treadmill or clothes dryer, causing a computer on the same electrical mains circuit to reboot. Then coupled EMI. Coupled EMI happens when the source and the receptor are close to each other but not electrically connected. Coupled EMI can be transmitted through electromagnetic induction or capacitance. Inducted or magnetically coupled EMI is the one of the type, and second one is a capacitively coupled EMI. Inducted or magnetic coupled EMI happens when a conductor's magnetic field induces an unwanted current in a nearby conductor. An example of inducted EMI is when a power cable and an audio cable are near to each other and a hum is heard on the audio line. Capacitively coupled EMI happens when two conductors are parallel and store a capacitive charge between them. Capacitively coupled EMI requires the conductors to be very close to each other together and is most common on electronic circuit boards or in groups of closely packed wires running long distances. So what is the difference between EMI and EMC? If you have a question on this, so how to elaborate this EMI and EMC in detail? So EMI is a term for radiation and EMC is the ability for a system to operate within the presence of radiation. How we can use any device, electronics device, in the presence of radiation from other devices? That gives you the idea of electromagnetic compatibility, means EMC. EMC is how well a device blocks EMI. So this is basic difference between the EMI and EMC. Okay, so EMC is the measure to avoid the EMI or to reduce the electromagnetic interference. More specifically, EMC, electromagnetic compatibility, measures how well electrical devices can function while being hit with EMI, released energy from another electrical device. While EMI is the problem and EMC sees how well that problem can be handled. Okay, so to combat EMI, electronics devices will have EMI shadings made up of materials like metals, rubbers and fabrics. So we should keep the various electronic devices inside the shading box, which has the coating of rubber, fabrics or metals. Nearly any electronics device can be interrupted by EMI and need to be tested for EMC. Testing for an EMC, electromagnetic compatibility, is especially important in products like pacemakers and hard drives where life and vital data are at risk. So it is necessary to do the electromagnetic compatibility for various devices, electronic devices. So which are the methods for minimizing the EMI and which are the shading techniques for the EMI. So this is very important part for the EMI and EMC. The best way to prevent EMI is to use a good quality electronic material like cables, wires, patch cords and instruments. All devices must be tested against emission standards to prevent them from causing excessive EMI in other devices. Proper shading is required for all the electronics instruments. Modern error correction and filters can also reduce the effect of nearby EMI sources. So filter plays an important role over here to avoid or to remove or to minimize the interference, electromagnetic interference. In high-speed networking, power lines should be separated from data lines. Conductive tape can also be used to block EMI. A Faraday gauge may be used to shield a device or room from outside EMI. Radio telescopes are often constructed in isolated areas away from population centers to reduce EMI. So this is the reason why we have the radio telescopes far away from the city areas. Okay. So in hospitals, it is required to keep cell phones switched off to prevent them from causing EMI in sensitive equipments. To reduce EMI, filtering, grounding and shielding is very essential. By using these techniques, we can minimize the electromagnetic interference. So one more reflection spot. Take a pause, 1 minute, and think on this question. How to prevent electromagnetic interference? Which are the methods, which are the shading methods or techniques to avoid or to minimize the electromagnetic interference? So these are the various EMI and EMC standards. We have the various applications in daily life, then common EMC standards here and significance of it. For example, medical application, we have the common standard IEC 6060112. This is a standard which regulates the safety and performance of medical equipment and systems under electromagnetic environments. Similarly, for the military application, we have the different standards which regulates electromagnetic emissions and susceptibility of the systems used in military applications. Then for commercial applications, for industrial application, then power station and substations, process control and measurement, switchgear and control, we have the various standards. Let us talk about the power station and substation. IEC TS 610065 is a common EMC standard used for this. Sets the immunity level for the equipment utilized in the generation, transmission and distribution of electricity. So, all the standards are very important for the EMC and this overcomes the electromagnetic interference. These are the references available online. You can check over here. Then if you have any queries, you can ask me at any time. I think you have got the various information about the EMI, EMC, minimizing techniques, shading techniques, and the types of EMI and EMC. I hope you have no doubt, and if you have any query, you can ask me at any time. So thank you students. Thank you all.